In section 2.5, we are looking at graphs of linear and quadratic functions. Graphs of linear and quadratic functions. So recall that a linear function is one that can be written in the form y equals ax plus b, while a quadratic function can be in the form y equals ax squared plus bx plus c, basically. All right. In order to sketch a linear function, let's start with the linear function. The graph of a linear function is called a straight line. Its graph is called a straight line. And in order to sketch the graph of a linear function, what you need to do is just to find two intercepts on the line, GHT straight. Two intercepts on the line and connect them, all right? An intercept is the point at which the graph intersects the axis. So an x-intercept is the point at which the graph of the function intersects the x-axis, while the y-intercept is the point at which the graph intersects the y-axis. So to sketch a straight line or the graph of a linear function, all you need to do is to find an x-intercept and a y-intercept and connect them in a line, a straight line, basically. And given a linear function of this form, to find its x-intercept, what you need to do is to set x equals 0 in this equation and solve, or set y equals 0 in this equation and solve for x, and to find its y-intercept. So in this case, with y equals 0, it means for x-intercept, ax plus b is 0, so that x is minus b over a. So the x-intercept is the point, it's the point minus b over a, 0, right? And to get the y-intercept now, you set x to 0 and solve for y. So y equals a times 0 plus b, so that y is equal to b. So it's the point 0 on the x, b on the y. Okay, 0 because we substituted x equals 0. Then we get y equals b. X equals 0, y equals b. Here we substituted y equals 0 and got x equals minus b over a. Y0, x minus b over a. So this point here is the x-intercept point, and this is the y-intercept point. So all you need to do is just to plot these 2 points on a Cartesian plane and connect them to get a straight line, basically. Let's look at some examples on how to sketch these straight lines in problems 2.5. So for instance, given y equals x plus 1, all right? So the intercepts will be x-intercept when x-intercept is obtained by setting y to 0 and getting x to minus 1. So it's the point minus 1, 0. And the y-intercept is obtained by setting x to 0, so it becomes a 0 plus x plus 1, 0 plus 1, which is 1. So the y-intercept is the point 0 on the x, 1 on the y. Okay, then we plot our graph. So our graph, typically that's our Cartesian plane, x-axis, y-axis, and we plot these points. So for the x-intercept, we have the point -1 on the x, 0 on the y. So it's that point. And we have the point 0 on the x, 1 on the y. It's that point. connect the 2 points to get your straight line. Okay, so basically this is how we plot straight lines. It's supposed to be straight. Okay, this is how we plot a straight line or the graph of a linear function. Okay, let's take one more example. Example number, let's take one more example. Y equals, this is number 9. Y equals 3x minus 5. Okay, so again, get our intercepts. X-intercept is obtained by setting y to 0 and solving for x. So it's the point, this is 5/3. 5/3, 0. And the y-intercept is obtained by setting x to 0 and solving for y. So y is -5. So it gives us the point 0 on the x, -5 on the y. Then we plot these 2 points and connect them in a line, basically, right? So plotting the point 5/3, 0. 5/3 should be somewhere there. 2 point something. 1 point something. Okay, so 5/3, 0 is that point, and 0 on the x, -5 on the y. -5, 0 is that point. Connect the two to give you a straight line. Connect the two to give you a straight line, and that is our straight line there. All right. Okay, so that's how to sketch a straight line. Let's then look at how to sketch the graph of a quadratic function. Okay, so graph of quadratic. So the graph of a quadratic function is called a parabola, just like that of a linear function is called a straight line or a line. That of a quadratic is called a parabola, like that. The graph of a quadratic function or a parabola. So in order to sketch a parabola, we have a number of factors ingredients that we need in order to sketch our graph. So we need the intercepts, both y and x intercepts. We need the vertex or turning point of the graph. We need the line of symmetry of the graph. Okay, and then we can then sketch our graph. Okay, we find the intercepts, the vertex or turning point. So the parabola looks very much like this or like this. Okay, remember, recall that or like this, a hill or a valley. So this happens whenever a is greater than 0, and this is when a is less than 0. Okay, the a I'm talking about is the a in y equals ax squared plus bx plus c. When this a is negative, we have our parabola in this form, like the hill-shaped. And if a is positive, our parabola takes this valley shape here. All right, basically. Okay, and this point where it turns is called its turning point or vertex. This point. Okay, it was coming up, then it turns and start going down. It's the turning point. It was going down, it turns and start going up. That's the turning point of the parabola. and then there is a line through the middle which divides our parabola into two equal arms, all right? Two equal parts. This is called the line of symmetry. It's called the line of symmetry. It divides the parabola into two equal halves, basically. Two equal halves. Called the line of symmetry. Okay, let's look at a typical example of how we can sketch a given parabola. Okay, we are still on problems 2.5. Problems 2.5. Let's look at number 26. Okay, look at number 26. It says given y equals negative x squared plus x minus 6. Negative x squared plus x minus 6 or plus 6. Okay, and we want to sketch this. So the first thing, the x-intercepts, okay, x-intercepts are obtained by setting the left-hand side to 0 and solving for x. So x squared plus x plus 6 equals 0. We want to solve this quadratic for x. Let's see if we can factorize. Factors of minus x squared are minus x and x. Factors of 6 are 3 and 2. We need x in the middle. X times 2 is minus 2x. X times 3 is plus 3x. Minus 2x plus 3x is x, which is our middle term. So that tells me these are my factors. So my factors will be minus x plus 3 times x plus 2 equals 0. So that minus x plus 3 is 0 and x is 3, or x plus 2 is 0 and x is minus 2. Okay, that's my x-intercepts. I need to get my y-intercept by setting x equals 0. So for y-intercepts, y is negative 0 squared plus 0 plus 6, which is 6. Okay, so my x-intercepts will be the points. I need to get the points because I have to plot them. X-intercepts will be the points. Let me just quickly take out this, give me space to write my x-intercept points. Will be the points 0 or 3, 0, and the point minus 2, 0. And we already said our y-intercept is 6, which is giving us the point 0, 6, basically y-intercepts. Okay, next we look for our turning point or vertex. So the formula for the turning point, it's x, it's a point, so it has an x and a y coordinate, all right? Its x coordinate is, for the turning point, its x coordinate is given by x equals negative b over 2a, all right? And its y coordinate will be f of negative b over 2a, basically. So x will be negative b. Remember, this is my a, x squared plus bx plus c. So my b there is 1. Negative b will be negative 1 over 2 times a. A is negative 1. -1, which is a half. And my y coordinate for the turning point will be substitute this half into the original function. So it will be minus a half squared, okay, minus a half squared, like that, plus half plus 6, which is minus 1/4 plus a half plus 6, which is a half plus 1/4 is 3/4 plus 6, 6 and 3/4. So it's going to be 6. Okay, it's a half minus 1/4 rather. It's minus 1/4 plus 6. So 6 minus 1/4, which is 24 minus 1 is 23/4, basically. Okay, so our vertex is the point a half, 23/4. That's our turning point. So once we've gotten our turning point, next is to get our line of symmetry. And our line of symmetry, okay, usually denoted by line of LOS, like that. Line of symmetry is given by the line x equals -b/2a, which in this case will be the line x equals -1/2. Okay, then we are ready to sketch our parabola. Okay, draw the Cartesian plane and sketch our parabola there. Okay, so the first things first, let's look at the intercepts. So we have the point 3, 0 and -2, 0. 3 on the x, 0 on the y. That point, -2 on the x, 0 on the y. That point is our x-intercept. Y-intercept is the point 0, 6. 0 on the x, 6 on the y. Y-intercept is the point 0, 6. 6 there, 0. And then our turning point is the point a half, 23/4. So 23/4 should be 5 point something. All right. Half on the x, somewhere there. 23/4 on the y. Somewhere here. Is it negative or positive? You have to be careful with that. Let's look at it. 6 minus 1/4, so it's positive 23/4. Okay, 23/4 is there, a half is here. So turning point is somewhere there. Okay, and our thing having a negative a value means it's turning like that. All right, basically. So it turns this way. Then we may not have it since 3/4. I think something is wrong somewhere with our turning point. Let's have a second look at it. I think we made a mistake with our signs there. All right. This is supposed to be a plus, okay, because a half minus 1/4 is positive 1/4, so that this should be 25/4, okay, which is actually 6 point something, okay. So if it's 6 point something greater than 6, That means our turning point will not be here. Our turning point will be somewhere slightly above 6 there at 25/4 and there. Okay, turning there or turning point. Okay, so we can then sketch our graph. So it goes through the x-intercepts, comes through the y-intercepts, turns there, and then comes down through the other x-intercept. Okay, comes down through the other x-intercept like this. Okay. And that's our parabola there. That's the parabola. Okay. Okay, let's see if we can take another example of the parabola. Number 25. Number 25. Number 25 says we should sketch x squared y equals x squared minus 4x plus 1. Okay, so again, we get our intercepts, x-intercepts, x squared minus 4x plus 1 equals 0. All right, we want to solve that. Let's try to factorize or factor. Let's try to factor our thing there. We get an x for x squared. I don't think it's factorable. Right, we are not getting the factors. Okay, and 1 so you can never get 4x there in the middle. Okay, now if we try using our quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac over 2a. We try using that to solve for x. We get x to be minus 4, which is 4, plus minus the square root of b squared is 16 minus 2ac minus 4ac, 4 times 1 times 1 over 2a, which is x is equal to 4 plus minus 16 minus 4 is 12, square root of 12 over 2. Okay, and square root of 12 is basically square root of 2 root 3. Okay, so which is 4 plus minus 2 root 3 over 2, which is the 2 cancels. 4 divided by 2 is 2, and this 2 cancels with that 2. 2 plus minus root 3. Okay, so our intercepts, our x-intercepts will be, our x-intercepts basically will be x equals 2 plus root 3 and x equals 2 minus root 3. All right, so we have the points 2 plus root 3, 0, and the points 2 minus root 3, 0. Okay, so those are our x-intercepts. Y-intercept will be, y-intercept is going to be y equals 0 squared minus 4 times 0 plus 1, which is 1. Okay, so it's the point 0 on the x, 1 on the y. So our y-intercept. Let's look at the vertex or turning point. So the turning point will be, the x coordinate is negative b over 2a, which is negative b. Our b there is negative 4. and our A is 1. So B is -4, so negative of -4 over 2 times 1, which is 4 over 2, which is 2. And our y coordinate will be substitute 2 into the original function, which is 2 squared minus 4 times 2 plus 1, which is 4 minus 8 plus 1, which is minus 4 plus 1, which is minus 3. Okay, so our turning point is the point 2 minus 3, basically. And our line of symmetry is the line x equals minus b over 2a, which is 2. Minus b over 2a is 2. Okay, and then we are ready then to sketch our parabola. Okay, we are ready to sketch our parabola. Okay, so first things first, we plot our intercepts. The x-intercepts are 2 plus root 3, 0. Now square root of 3 is 1 point something, 1.333 something. All right, so square root of 3 plus 2 should be 3 point something, basically. Okay, and this should be 3 point, you can get that from your calculator, and this should be 1 point something. Okay, 0. So the first one is going to be 3 point something 0, and then the next one is 1 point something 0. Okay, so first one is 1 point something 0. So if 1 point something should be there, which is 2 minus root 3, that point, and 2 plus root 3, 0. Okay, those are our x-intercepts. Our y-intercept is 0, 1. Okay, we call that. That's our y-intercept there, 0, 1. And our turning point is 2 minus 3. Y-intercept is 0 on the x, 1 on the y. And our turning point is 2 on the x, -3 on the y. 2 on the x, -3 on the y. Turning point, 2 on the x. Okay. So 2 should be somewhere in between the -3 on the y. -3. Okay. So I'm ready to sketch my graph. So my A is greater than 0 here. A is greater than 0. So my graph will look like that. Okay. Okay, so it should pass through both the y and x intercepts, come down, turn there at the turning point, and then go through the other intercept like that. Okay, and this is then the graph of that parabola. So let's look at the domain and the range of these graphs. So the domain of this graph will be all real numbers. Okay, this is all x values for which the function is defined. So it goes up until infinity, goes up until infinity. So the domain will be the interval minus infinity, infinity, or all real numbers. It's the same thing. And the range will be the set of y values, all right, for the function. So look at the y-axis. The y-axis can only start from -3. Right? You agree with me that this function can never go below this point, right? It turns here and it can only go away from this point upwards and not downwards. So the y values will only take values from minus 3 and then goes up to infinity. So that the range will be interval minus 3, infinity. All right, minus 3, infinity. Minus 3 included because minus 3 is at this point on top of the graph where it's the turning point. Okay, 2 minus 3. That point there. So that's then the graph of that parabola and its domain and range. Let's quickly look at the domain and the range of the previous one that we did. So for this one, its domain is always all real numbers. Take note, for parabolas and linear functions, their domains are always all real numbers. Now the range is the set of y values. You agree with me that my y values can never go beyond this point. They can only go further away like that. All right. They can never go above this point. So y values will come from down there at minus infinity. Range will now move from minus infinity down, 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 where this arrow will go and end. We don't know where it will be, so it's at minus infinity. From minus infinity, because it's going towards the negative, down more and more negative, right? Minus infinity to that point, which is 25/4. That's the range of that function. Just by observing it on the graph, you see the range of the function, where meanwhile the domain is always all real numbers. So that's that about graphs of linear and